I should have recorded that because I need to update that on, put that on YouTube. All right, so yeah, so essentially today we'll be looking at different types of heat. So like you will be better equipped to answer, to solve the problems that the clients have, whichever client you were to choose. So for that, we're gonna go on Summit. So I think everybody's name whom I'm seeing here I've seen them on Summit. So what I'm gonna do, I'm gonna put the code on Summit still, just in case someone here has not enrolled yet in the class. So, and it, also as a record for attendance, can everybody say something in the chat box? Like I see Tyquil and Salima already say hi or something. So just put something in the chat box as a record for attendance. Hi, Kashmir. And also, I also put the code on Summit in case someone here has not yet enrolled in my class in Summit. And then we are going to go straight to Summit. So what am I gonna do? What are we doing here? So let me go to share. I'm gonna go to my desktop. So this is the project. It's called Don't Feel the Heat. Everybody should be on the project. I see there are two people who just, let me see. Tyquil is here. Kashmir, okay, I'm gonna allow you to. Deja, Gia. Where's Rara? Ranisha. Somebody who's here is not on the class. So let me assign these people who just checked in. Assign all. Save the assignment. Let me see who's here, who's not on Summit. Closed. Everyone, please, you have to join the class on Summit. And if you just logged in, please put something in the chat box as a record for attendance. So I have.
I talked to Miss Christina today. She's going to help me at 12:30 log into Summit on my laptop because we've been trying to fix it since I first started, like, I think a week or two ago, but it's not working for me like at all. None of my classes is working. And I told all my teachers and stuff, so.
All right, thank you for letting me know. So are you saying your computer is not turning on or your Summit is not, you're not able to access your Summit?
So when I try to log on to Summit on my phone, it works, but I can't really like scroll. You know how you guys scroll down and then click the side, stuff like that. I can't do that on my phone because I feel like maybe the screen too small or whatever, but I tried to do it on my laptop and it keeps saying, like, when I try to log into my laptop with my Yes Philly login, it keeps saying contact your admin, but I can't log into Summit while I'm still logged into my Phila SD because it's not going to let me.
I see what you're saying. So that's a Miss Christina a question. So she's the right person to help you. All right, but I think so when she does that, also let me see. Also make sure that she before you leave that call with her, make sure you are also enrolled in all your classes because you, besides the technical issue that you're having, you also not enrolled in my class. You understand?
Yes, I'll tell her.
All right, cool. Everybody here, Faye, hi, how are you? Please enroll in the class. Oh, yes, you are. All right, so that being said, I want us to just refresh. Just for, I think I had those slides open. Planned. All right, so there's something I wanted you guys to see. What did I do with this slide? Just hang in there with me. Nope. Introducing the client. Okay. So this is a nice get to know each other, like building bond activity where you guys would have built a towel together, but we can't do that because we are not in together. So let me introduce you guys to the clients that you guys are going to meet, but all hypothetically, of course. So the clients are, you're gonna play the role of engineers and people, those people, they're gonna pay you to solve a problem for them. So let's look at the first client. The first client has an ice delivery service. And what is the problem that they have? Ice melts quickly when being moved from one place to another. We need a container that will keep a piece of ice frozen as much as possible for a 15-minute delivery. So you can imagine their truck or whatever it is that they're using to move the ice from one place to another is not keeping it cool enough. So who has the problem? IDS, a company that deliver ice for parties. And why is this a problem? If IDS can't keep ice from melting too much, they'll go out of business. Because imagine somebody's having a birthday party or whatever kind of party, and they're expecting a block of ice from you, and by the time the ice get there, it's just a little icicle. It's not good. So somebody might say, okay, I want to solve this problem. All right. Second client, Stanford Salmon Research Center. What is the problem? Scientists keep getting frostbite when putting their hands into extremely cold water while researching salmon in Alaska. They need a glove that will keep their hands both dry and warm. Who has the problem? The scientist at the SSRC. Why is this a problem? The scientists can't do good research if they have to keep pulling their hands out of the water all the time. So that's the second problem. Let me present. That's the second problem. Third client, Bicycle Burrito. What is the problem? Bicycle Burritos is a new restaurant that delivers burritos by bicycle. The problem is that the burritos often get cold before they get there. They need a container for the burritos that will keep them hot and will also fit into backpack. Who has the problem? Delivery people at Bicycle Burrito. That makes me think about the two young Black guys who have like a delivery service for Black restaurants. So anyway, so you can imagine the backpack that people use to deliver food, but they need one that's gonna keep the food warm for a much longer period of time. What is the problem? If the burritos keep getting cold, the company will lose customers and go out of business. Fourth client, Ford Motor Company. What is the problem? When people put cold drinks into their cup holders in their car, those drinks get warm quickly. Ford wants a new cup holder design that will help keep drinks colder longer. Who has the problem? Ford Motor Company. What is the problem? Warm drinks are annoying. If you don't want it to be warm, if you buy a cool drink, you don't want it to be warm. Plus, if Ford can get this into their cars first, they will maybe be able to get people to buy their cars more. I think I think we had more clients than that. All right, so those are the clients. So later in this project, you and your team, but obviously it's just you guys, those are the tasks that you're going to be completing. But ultimately, I wanted you guys to see the type of clients and the type of problems that you will be solving and designing in this project. That being said, if you're asking yourself, how are we going to do this? It's going to be hard. It's not going to be hard once you learn the content and you apply yourself. So now let's go to Summit. And everybody should have access to the project. And we're gonna go to checkpoint 1, intro to types of energy. So the first thing we're gonna talk about, we need to understand is different types of energy. So here we are talking about thermal energy, heat energy. So let's look at the different types of energy. So you're gonna click here, you're gonna go to the project. Everybody should be able to find the project in their class. So let me see if I can see a student view. Who's here? Gia, is it okay if I look it up as you so I can, so if, just in case somebody's struggling to find the project? Is it okay if I,
Oh my.
All right, thank you very much, sweetheart. So.
Can you assign me the checkpoints?
You should, yeah, hold on a second. So everybody should, so this is a student view. So once you log into your Summit probably looks like this. You go under year. Under year, you should be seeing all your classes. And this is the physical science class. So you're gonna go to the project, Don't Feel the Heat. And you should be able to see your project overview, which is what this project is about, what you're gonna be learning, and then this rubric, the skills that we're gonna be grading, and you can click view rubric so you can see your rubric and then the key concepts. And today we are studying checkpoint 1. And then you click here, intro to types of energy. Like right here, the title, it's you see it's underlined, you click on it and it takes you there. All right, so let me go back. Exit student view. Thank you, Gia. Stop viewing as Gianna Personal. And somebody said they have not been assigned. Okay, so select checkpoint. Kashmir, you should be able to see it too because your name is right here and it's 26 out of 26 people with access to the first checkpoint.
I see it now.
All right, cool. All right, close. So types of energy, you click here. So the way I designed this first checkpoint, because what I'm doing a lot of modification to this project because I realized when we have checkpoints that have a bunch of tasks that you guys need to do at once, I feel like people just get exhausted. So I'm breaking down the checkpoints and even adding checkpoints just to make the workload lighter. So here is an intro to energy, what energy is, types and forms of energy. And at the end of each paragraph, so I think we have 4 main paragraphs. At the end of each paragraph, I type the questions that I need you to answer for me. So here, types and form of energy. So I said, after you read it, I need you to tell me 3 types of energy that you have read. And there are more energy than the energy listed in this article.
So we can give more information.
You say what?
So we can give more information.
Yes. Give 2 examples of how energy can be transferred into other forms. So those 2 questions, you're gonna answer them from this paragraph. Then you move on, potential and kinetic energy. And then here, I'm asking you to give me the definition of potential energy and give me an example. Same for kinetic energy, what it is, and also give an example. Once you click on this box and you press enter, it expands. So it's just because you're seeing a little space after question number 2 doesn't mean that you can't add space, because you can. Mechanical energy. What is mechanical energy? Mechanical energy is actually really interesting because it's actually an energy that actually uses 2 other kinds of energy in order for it to function. So here, it is so interesting. I'm asking you to explain when and how a hammer has both potential and kinetic energy. A hammer is actually a tool that uses mechanical energy, but mechanical energy turned out to itself use 2 kinds of energy. And then heat energy, also called thermal energy. And here there are 4 questions related to this paragraph. What are all substances made up of? What are molecules always doing? What is heat energy? What is the difference in the type of movement in mechanical energy and heat energy? So if you guys were to apply yourself and feel really disciplined, you can actually complete this right here and be done with it. So because we're only meeting today for this week, so if we had school on Thursday, I would have said this is due by Thursday. So I'm still gonna say it's due this week. So let's say you can finish it today, tomorrow, or Wednesday, but Wednesday is the day that I'm gonna update your grade for this assignment. So you have up until Wednesday to finish it. However, it's a good idea to do it right here, right now. So let's read this. Introduction. And if I call your name and you want to read, that would be very cool and nice if you want to read. Energy. Why is energy important? Another word that can be used for energy is power. Energy is another word for power. Energy makes things move. It makes machine works. Energy also makes living things grow. Types and forms of energy. Energy exists in many different forms. Animals get energy from eating food. Electrical energy is associated with tiny units called atoms that makes everything in the universe. Energy is created when particles called electrons move from one atom to another. Heat and light are also forms of energy. One form of energy can also be transferred into another. Check this out. Through a battery, stored chemical energy changes into electric energy. So when you buy a battery, when you're touching a battery, you're not feeling anything. You're not feeling like an electric shock, because while you're holding the battery, all of the energy stored in the battery is in the form of chemical energy. However, once you put it into like a flashlight or whatever you put your batteries in, all the outlets and all the architecture design inside your device, that chemical energy is then transferred into electric energy. So energy cannot be created nor destroyed, but it can be transferred. Same with light bulb electric energy. How cool is that? We need electricity in our house. Once you turn on your light bulb, this is like electric energy inside of it. And how is it transferred? You get light. And also if you touch your light bulb, isn't it hot? So that electric energy is transferred into light and heat. Then you need to give me 3 types of energy and 2 examples of how energy can be transferred into other forms. Potential energy. Faye, would you like to read this paragraph?
I just saw the best of it for that.
If you want. If you don't want to, that's cool. Board, can you guys please be quiet? Tyquil, would you like to read this paragraph? I'm giving out points for reading. Who would like to read? If somebody would like to read, you can just volunteer. Also remember to put your name down, to write something in the chat as a record for attendance. Otherwise, if something happens and I don't remember you being here, I have no record of you being here. Well,
I have a question. If I could all do this by Wednesday, can I leave now?
no, you're supposed to be in class, unless of course there's an emergency, but you're supposed to be in class.
Yeah, I have to go down to my mom's house. My
Right.
family's in North Carolina, and
You're supposed to be in class right now, Faye.
can I like stay on class on my phone?
Absolutely. Absolutely.
Okay, so I can transfer it to my phone.
Oh, then you
Absolutely.
good?
Okay, thank you.
Yeah, I told him. I said, "Come, no, listen."
Miss Francois,
Yes.
can I read?
Yes, sweetie pie. Thank you.
Okay. Each of the, can you scroll down a little bit?
Mm-hmm.
Okay. Each of the different forms of energy can be described as either potential energy or kinetic energy. Potential energy is stored energy. For example, the chemical energy of food is stored energy. When people eat, their bodies change the stored energy into movement energy, such as heat energy or mechanical energy. Potential energy can also come from the position of an object. An object with potential energy, because of its position, has the ability or potential to move. For example, potential energy is stored in a rock perched on the cliff and in an arrow stretched back on a bowstring. If the cliff crumbles under the rock falls. If the string is let go, it moves forward and pushes the arrow through the air.
Very good. Go ahead, continue.
As the rock and the arrow move, they gain kinetic energy. Kinetic energy is moving energy. All moving objects have kinetic energy, even atoms. The total random moving energy of all of the atoms and molecules in the object is called heat energy or thermal energy. The moving energy of a rock rolling down a hill is called mechanical energy.
Thank you very much. That was a good read. So one way you guys can know the difference between potential and kinetic energy, I think I realized that when I was little, when I was learning about this, and I was like, how do I remember the difference between potential and kinetic energy? Remember potential, when somebody has, it's like kids. We look at kids and they say we have potential. They are not yet what they could be. That's why it's beautiful for kids to have potential. But as adult, you don't want to be just potential. You want to be actual. You want to actualize yourself. So if as a kid, you can say, oh, this kid has potential to become a doctor, a lawyer, based on how smart they are, what they are interested in. So potential energy is stored energy that can do something, the ability to do something later on. That's why if you put a rock on top of a hill, that rock is not moving. It has potential energy because with any little push, it's going to roll down and it's going to crash everything on its way because it has so much potential energy from having been raised high up into a mountain. Or food store chemical energy, which is also potential energy, because when the food has potential energy because once you eat it, now suddenly you're not feeling weak anymore. Suddenly you feel like you have the energy to run, you have the energy to steady, because your brain, your body, your bones, everything have been fueled from this chemical energy, which was potential energy, and now you can transfer it into kinetic energy. And then once you know the difference between potential energy that's stored somewhere, kinetic energy, you want to think about movement. That thing is moving, this rock is rolling, this person is talking, this person is walking because their belly is full of food, and that energy is being transferred. So that's what I want you to understand, the difference. What is potential energy? And you give an example. And what is kinetic energy? And you give an example. Mechanical energy. Mechanical energy is potential energy plus kinetic energy. This is really interesting, and you guys are going to see why. Unlike other forms of energy, mechanical energy can exist as both potential energy and kinetic energy. And when you think about mechanical, like you're going to a mechanic to fix your car, okay? Mechanical energy. It is all the energy that an object has because it is in motion. Kinetic energy and its position, potential energy. Machines use mechanical energy to do work. For instance, that's a good example right there. A hammer uses mechanical energy to drive a nail into a board. When the hammer is raised, the thing that I want you guys to think about movement is that when you raise something, when you lift something up, there is a moment where that movement stops, whether you feel it or not. When somebody raises a hammer, you're about to bang it on something. The moment you lift it up, a slight second before your hands start going down, there's a pause that happened. When that pause happened, because that hammer has been lifted, it has potential energy. When the hammer is raised, it has potential energy from the work done in lifting it. When the hammer is now moving down, that potential energy becomes kinetic energy, because now the hammer can do work by driving the nail into the board. When the hammer hits the nail, energy is transferred to the nail and then to the board. Okay, so mechanical energy, you want to think about two forms of energy combined in there: potential energy and kinetic energy, because before the things start moving, it must have had stored energy in order for it to start moving. And then here you explain, you can put it in your own word, explain when and how a hammer has both potential and kinetic energy. And then heat energy, which is what we're going to be mostly focused on this term. Heat energy is also called thermal energy. Isn't there like a type of clothing you guys call thermal? It's, you know, I'm not American, but yeah, right? Because why do people call it like that? Where do you guys think that name come from?
Because they store heat.
Is it?
Yeah, it keeps you warm. You don't see people walking out with those kind of clothes during the summer, but once winter comes, that's when people start using them. Okay, all substances are made up of particles. That's kind of like a universal law, and this is the type of thing that you got knowledge that you guys want to have too. You know, somebody might be like, oh, I'm not going to be a scientist or something like that, but if you've taken a science class, you need to know all substances, from the air that we're breathing, what you are made of, the table you're sitting on, the computer, everything is made of particles or bits called molecules. Molecules are always moving around randomly within a substance. Even with ice, that's why ice is so cold, because the molecules are moving so little. There's so little movement that there's no heat, so it becomes cold. But if the more movement an object has, the warmer it is. So molecules are always moving around randomly within a substance. Heat energy is a total moving energy. You take an average of all the you add all the energy and you get heat energy. Heat energy is the total moving energy or kinetic energy of all the molecules in a substance. All substances have heat energy, since the molecules that make up all substances are always moving. So if you take a really, really, really hard ice, and let's say it's like -2 degrees or 3 degrees, versus a cup of water that might be room temperature 27 degrees or whatever. The ice also have heat. It's just that the molecules are moving so slowly that it feels cold, but it's not like an absence of heat. It's just very, very low heat, versus something where, like boiling water, you can literally see the bubbles. That's how fast the molecules are moving in boiling water. So you guys always have to remember, there is no such thing as like an absence of heat. It's just how fast the molecules of an object is moving tells you, once you touch that thing, if it's going to be hot or if it's going to be cold. Mechanical energy and heat energy involves different types. I'm sorry, is that a problem? Okay. Mechanical energy and heat energy involve different types of movement. This is really cool too. Moving mechanical energy involves all the molecules of an object moving together, such as rock rolling downhill. On the other hand, heat energy involves the disordered movement of molecule inside of object. If I have a hot cup of water, the cup is not moving. The molecules of the water are moving. That's why the water is hot. That's heat energy. Versus mechanical energy, if a rock is moving, the whole rock is moving. It's not like the rock is standing and then it has this great mechanical energy. It really comes when it starts moving. So the difference, you have to see the difference between the movement. They both involve movement, but how is this movement happening? At what level? Okay, so what are all substances made of? What are molecules always doing? What is heat energy? And what is the difference in the type of movement in mechanical energy and heat energy? So that's what you guys have to do today. It's pretty simple. Let me see, 1, 2, 3, 4, 5, 9 questions that you guys have to answer. I think it would be cool if you could just, because we have, what, 20 more minutes? Hopefully you guys were paying attention. So you guys can just answer the questions and be done, or you have until Wednesday. But Wednesday, about 1 o'clock, if this document is not done, you're gonna see a big red on your first progress, on your first checkpoint, which is not good. It really isn't.
Excuse me.
Yes. Hi.
Okay, so I don't know if you're on Summit or not, and I am following. I can hear you, but I am also working.
You say what? I'm sorry.
So I can hear you, but
Mhm.
I am also working.
No,
So
I
I'm
understand.
following along, but I really can't. I noticed this be recorded. I don't know if you're going to post this up, but if you do, can you send it to my email so I can just finish it?
Absolutely. So the work is on Summit. So it's good that you are paying attention. So the work is on Summit. You have to go to Summit. It's the first.
I was listening.
Yes, it's the first checkpoint of the project. And then all the explanation that I was giving, I